So as we continue our exploration of the microscope, one of the most important things that we have to understand when we're using a microscope is how big everything is, or really with the microscope, how small everything is. How little are we talking about? And this gives us a good frame of reference as we are looking at different cells as we look at Lab 3. This really helps us to understand the comparison of things. So in order for us to do that, the first thing we have to understand is how big is the area that we are actually looking at. So with your microscopes, you are going to follow procedure 2.3 and actually measure the diameter of our field of view. Now we have three objectives, right? We have the 4x, which is our scanning, the 10x, which is our low power, and then the 40x, which is our high power. Now they are all related to one another because our microscopes are parfocaled and par-centered. That means that we have a relationship between each one of these. So in order for us to use and actually measure our field of view, what we are going to use is this little thing that's kind of out of focus right now. Let me pull it into focus, which is called a stage micrometer. Basically, it's a teeny tiny ruler. This teeny tiny ruler is what you're going to use to measure your field of view. Now, right now I am on 4x, right? The scanning, which is the lowest, which is what you should always start with no matter what. So as we start here, we have one stage micrometer that is 2 millimeters long. So remember, 2 millimeters, pretty tiny, and we can measure that as 1 millimeter, 2 millimeters, and then we can use the dashes in the middle for points, right? So you have, let me move this. So this is 1.5 millimeters, which would make this 1.6, 7, 8, and so forth. Now, one of the things you're going to discover as we are looking at this right now is that the stage micrometer does not take up the whole field of view when we're on 4x, which means we can't use this stage micrometer to measure 4x. You will not measure the 4x objective, a field of view. What you are going to do is measure the 10x and then use that in proportion with a little bit of mathematics, just a little bit of math. It'll be okay, just a bit. And you are going to figure out how big this is. Now, the computer and camera that I'm using on the microscope right now gives us a little bit smaller of our field of view than you will see actually in the microscope when you look because of where the camera is placed. But I'm going to give you an idea of what you're going to be looking at. So if we tried to measure here, what we would have to do is get this in close to the center as possible and then move it so that the 0 is all the way to the side. Right, so okay, the 2 only goes this far, right? We still have this whole area here that needs to be measured. So we can't really do that accurately. So just don't even try. That's what I say, don't even try, just move on. So what you are actually going to be doing is moving to 10x and measuring the field of view there. So again, what you'll have to do is take the micrometer and put it as close to the center of your screen as possible. And then you're going to move from the 4x to the 10x. So again, we've zoomed in quite a bit and we need to adjust a little bit so that we can see all of our numbers. We need to adjust our fine focus a little bit so we can read this a little bit more clearly. So then what we need to do is line this up so that we can measure accurately. So again, you'll be using the mechanical stage knobs in order to move this around. So you'll find the 0 here. So what you'll need to do is get that 0 as close to the center as close to the edge as possible, which again on your scope will be a little easier. The camera and I are fighting right now. All right, so that's about there. And then you're going to measure how big this is. You're going to literally count how many lines there are, right? So if this is 0, here we have 1, 2, 3, 4, and 5, right? Here's your 0.5, 6, 7, 8, 9, 10 to 1, and then 1, 2, 3. So this has 13 lines where it is 1.3 millimeters in diameter. So again, you're going to be measuring a circle, so you're going to have to do this as close to the center as possible, and again, it will be bigger than this. But the field of view I'm looking at on this microscope, on this specific field of view, is 1.3 millimeters. So if I had one cell that took up the whole thing, it would be 1.3 millimeters in diameter. If I had it that took up half, right, it would be about 1.7-ish millimeters in diameter. If it took up a quarter, right, it would be like 0.4-ish in diameter. So you get the point, right? We can estimate how big a cell is based upon how big our field of view is. So you're going to measure at 10x, which is again what we're looking at here, and then you're going to do the math to figure out 4x and 10x using the the equation that's on page 18 in procedure 2.3 in your lab book, and you're going to be filling out the table that's on page 19. So just to give you an idea, so right now we're at 10x, right? The reason that we can't measure for 40x, so what I'm going to do, I'm going to zoom in again. So I'm going to 40x, and this is what the ruler looks like under 40x. Even if I made this as clear as can be, measuring this accurately is basically impossible, right? Like our number, here's our number, this is our, it would be very challenging. So I'm just showing you this to show you why we aren't measuring our 40x. It is basically impossible to do. So you are going to, again, be measuring at 10x, and then you are going to be using the equation to figure out what the other two are, because they will be related. So the field of view diameter will just be the length here, and then you're going to also look at it in micrometers. So again, remember, let's zoom all the way out, that this is in millimeters. You also are going to be using some things in micrometers or micrometers this semester, which is notated by the little the weird looking U that is listed in your lab book, and you have it in the table 2.1 on page 19. You are just, in order to convert from millimeters to micrometers, it's a factor of 1,000. So all you have to do is multiply by 1,000. So our diameter at 10x in this example, again, remember, your microscope will not be this small. It'll be bigger than this. Ours was 1.3 millimeters, which means times 1,000, that would be 1,300 micrometers that you would be converting for. So you should be able to know how to do that as well.